or 1 February the 8th. Well, talking about impressive lifts, I just watched some. I mean, I've been watching these videos all the time. It just, after a while, you just want to go back and then rewatch them. There's the one, Marsaim, the 400 kilo squat. That one's ridiculous. And he also have like 10 reps at 320 kilos, 5x5 at 350. Yeah, this is just unreal. All right, and then you move on. What do you see? You see Gabriel Sinclair, 240 kilo front squat without warm-up. It's like, what the hell? And then always in this kind of quest, you have to end with clock off 225 kilo push press. Man, I just look at that every time I see it. That was just, my head cannot wrap around that. It's impossible to wrap around. And what type of thing is that? Who did that? 225 kilo push press. Man, I just look at that and it's like, wow. I can't even deadlift 225 kilos. I can't even deadlift 200 kilos, I think. I mean, my best ever deadlift is barely 200 kilos. Yeah, because that's 440 pounds. I don't think I ever deadlift that. Getting close, but no. I don't think I'll ever do that. If I ever need to deadlift that, it will be a clean deadlift. We'll see. I never really push my deadlift because my back strength is way above my squat strength. So there's no point training the back strength to push my classic lifts up. Yeah, I need to get my squat up. Talking about squat, I did 290 pounds today for 3 sets of 3. I was quite happy with it. Yeah, I still dream, it's okay to dream. I dream one day I'll be able to squat. Let's don't say 200 kilos, but maybe 180 kilos. All right. Maybe you gotta train smart, you gotta train smart. Otherwise, never get there. All right, let's see. What the hell is this today? Naming a company. You're given an array of string ideas that represents a list of names to be used in the process of naming a company. The process of naming a company is as follows. Choose 2 distinct names from ideas. Call them idea A and idea B. Everything in ideas are unique. Just pick 2. If both of the new names are not, swap the first letter of idea A and idea B with each other, or swap them. If both of the new names are not found in ideas, then the name idea A, idea B concatenation, separated by a space, is a valid company name. Otherwise, it is not a valid name. Return the number of distinct valid names. Okay, so we can pick 2, coffee and donuts. So it will be Duffy and Conuts. That's a valid name. Coffee and time. Oh my lord. Donuts and coffee. So 3 pairs. So each one, because after you swap the first letter, it doesn't really matter, right? It doesn't really matter. Just swap the first. So it's the same. So we just need to pick 2, right? Any 2. We have, 5 times 10 to the 4th. And we'll swap them. And if one works, then the other one works as well. Now, donuts and time. That will be donuts and dime. That's good. And we can reverse it, right? That's 2 pairs. The third pair is donuts and toffee. That'll be donuts and Duffy. That's also good. Coffee and time doesn't work because toffee is in it. If both are not found, then that's good. So coffee and time and coffee. And then coffee and toffee if you swap or toffee and coffee, that is not going to work. Lack and back, if I swap, no valid selections. This one screams try at me, you know? And we start with all unique, right? So what we can do, if we know anything that cannot, because if you swap out the first, right? You pick two, you swap out the first, and then one of them is inside. That just means for this, we cannot start with anything, which means the remaining, right? If the remainings are the same, if you have two words, right? If you have two words who have the same remaining letters, right? And then of course they cannot do it. Yeah, that's how it is in it, right? That's how you find repeat, is you get a word, right? And then you have 26 options. And then inside your ideas, there's another one with the same remaining and a different front. So what we're doing here is try to find out a mod is 5 times 10 to the 4th. How many of them have the same endings, right? Just except from the front, the remaining are the same. Okay? And if you find that, each one of those can form, it can form a company name with anybody else that doesn't belong to the same group, right? So basically, we can do a reverse try. I was trying to think if we can do it without try. You know, I kind of don't want to do try. But if we don't do try, how are you going to compare? You're going to have to, well, you can still compare, right? You can still do so. Because the length is 10. So you can just go one by one, right? You go the first one, and that could be the key. The remaining can be the key. And key and value. And the value will be at most 26. Because it's the first letter. At most you have 26 different possibilities. So for each one is only 26. But you can have a giant dictionary. So you're going to start, you pick that, you get the first letter. And you pick that, get the first. You don't even care about the first letter is what. You just say things ending in something, we have how many. Things ending in something, we have how many, right? So at the end of the day, you're going to have a giant dictionary with a bunch of numbers. And for each number, right? For each number, anything that's within cannot form, right? So it has to be one of this with one on the other side. So it'll be this multiplied by the other one. This multiplied by the other one. This multiplied by the other one, right? So if I have, eventually we end up with something like x1, x2, x3, all the way to, I don't know, xn. So we need to do x1 times x2, because anyone can be paired with that. This can be paired with this, and then they, ooh, hold on. No. You can only pick one of them. No, not really one of them. So you have bunch, right? So we can pick one with the letter, right? So you need to know on all the others which one does not have a letter that's inside as well. That's what you need to do. So, okay, so we have let's say a set with a bunch of letters. Do we need a second one? Because what I need to know is that's still going to be a lot. That is still going to be a lot of, because each one we have at most 26 options, right? We have 26 options. So we need to know how many is not in there, right? Because we can say, because anyone can pair with something that it's not inside, right? That's not inside. So we need to do, we'll say this suffix compare with this suffix. Then how do we know? Well, that's just too many. That is too many. There are too many suffixes. Too many suffixes. If I can know, let's say the first suffix, we have certain letter that it's eligible. Then what I want to know, and then the other one has to consider this as well, right? You have these are eligible, and the other one has certain things are eligible. We start with this, and the other one have this, and if we want to pair these together, we only choose the letters that does not exist in the first one, okay, and choose the letter in the first one that does not exist in the second one. Choose the letter that does not exist in the first one, so we find those letters. Choose the letter that does not exist in the second one, we find the letters, and those can be used. Those can be used, and then we multiply them. But the thing is, we have 5 times 10 to the 4th, and they're all unique, right? They're all unique. And after we do this dictionary, this mapping, we can have 5 times 10 to the 4th. We can have that many, right? We can have that many. We can have that many. If we have that many, how do we count? So the first one compare with the remaining, right? As long as, well, not the remaining, the first one multiplied by this, first one multiplied by this. So the first one need to multiply by the count, by the sum of the remaining. But the sum, let me think again. If I say I pick all of this, multiply by all of that, and then minus the ones that cannot form. And what do you mean the one that cannot form? Well, the one cannot form is if the one and the first one is inside the second one, right? So, and the ones in the second one is inside the first one. So if we do a intersection, but the intersection is, hold on, let me think. if we do the first one minus the second one, we'll get the thing that does not exist in the second one. And if we second minus the first, we'll get the thing that does not exist in the second, right? Because if they both exist, those will be eliminated. So this will be remaining. So this are the one that can do. This is the one that can do. So we can do this minus thing. Okay, so set minus set. Set minus set. Set minus set. Set minus set. But dear Lord, that's a lot of computation. Gotta be an easier way. Gotta be, man. If I know, right, we have the first one. We know the first one has the starting letter. Let's say ABC. This is the starting letter ABC, right? So it cannot match with anything start with ABC. So it has to match with something that starts with the remaining, right? So if it's A, this, we need to match with, start with at least D, because you cannot match B. Match B will be the same. So you need to find anything that starts with D. How many of them starts with D? Right? So starts with D, and it can be guaranteed that the thing starts with D does not have the same suffix. Ooh, this one might have some interesting. So we built two. We built two mapping. The first mapping is a suffix mapping. Then we find for each suffix what are the starting letters. And then the second mapping is a prefix mapping. So for every first letter, right? For every first letter, we count how many are in there. Like the total number of things are in has the same prefix. And then for each suffix mapping, right, we have a bunch of first letters. And then for each one, now for all of them, it has to be the sum of the remainder, the rest. Sum of those, because all of them can be matched, because they can move here, and this one can move there. That is not true. Wait, no, that is true. Because they start with, like, yeah, let's say we have ABC, right? We have some suffix, and then we have ABC. They all match to the suffix. And then we look for the prefix D, and we have a bunch of words start with D. And every one of them can be paired with this, because it starts with D, D something something. And I've moved A to it. Ooh, that is not true. That is not completely true, because we move D to that one works, but A we move here. Something might not work. Something might not work. So we need to look, so when A moved down, so we need to see, starting from A, right? So we go look for A. So A is going to be a giant list as well, right? A is going to be a giant list. Yeah, so we have some suffix, okay? Or some suffix, and then we have A, B, and C, right? So that's A sub, B sub, C sub. And then I need to go to look at D, E, F, all the way to Z. And they also have suffix, bunch of suffix, right? And I know by swapping D for this one, for the first one, we find something that doesn't exist. But when we do the swap, A is gonna come in, so everything will be starting with A. Then how do we know what, like which one of these does not exist originally inside? How do we know? Well, we know because these are suffixes, and we know we have. What if these suffixes, we also do we can do a set, or we can do a count. It doesn't really matter. It doesn't really matter, right? So what we need to do is go to this suffix. So we have another suffix. But then you have to go through the suffix one by one. Okay? You have to do this one by one. I do not want to go through this one by one. That's what I want. That's what I don't want to do. I don't want to do this one by one. Because if I do this one by one, because I have to go through D, E, F, every single one, right? And then, because I swap this in, yeah, how do I know this thing is not part of the original ideas? Lordy. Oh. So these we start with D, right? And if we swap A to it, we can go to A and find how many both exist in A something and a D something. Which is the same to say we go to the suffix and see if A is in it. But then I have to go through every single suffix, every single one of them. Okay? I have to go through every single one of them. And I do not intend to do so. Every single suffix. I don't know, man. Every single suffix seems to be... We go through every single one. Every single one. Well, we can go through that. Every single suffix. And for each suffix, we go to its and see if... Because all these suffixes are unique, right? So if we do the prefix, all of these are unique, okay? These are unique. And I just want to go through each one of them. We go to the first one, and we know what they have. And we just say if A is in it. If A is not in it, then that's a pair. Right? The next one, so that's O1. Now we can do O1. So we have to go through all of this. All of this, all of this, all of this, all of this. And then we start with B. Go through all of this, all of this, all of... I mean, we can just start with... Yeah, we have those, right? Yeah, we have to go A, and then we go through everything to check. Through B, anything we check. C, and anything we check. That is going to take a long time. I feel it's going to take a long time, but we can try. We can try, right? We can try. I'm gonna give it a shot. If it's not right, then we figure something else. So we basically built two things. Do we need counter? We actually do not need counter. And if we can avoid duplicates, well, shoot, duplicates. Duplicates. Like if we sorted it. If we sorted it, and then this taking care of everybody. And this, wait, what, like you have to remove this? Ooh, yeah, you might be able to. You can remove it. So for the first one, right, suffix, you go through all of these. You go through from A, you can remove that, right? B, you remove that. C, you remove that. This is cannot do. D, it's not in this, so we can find. So we did this and this, and then we multiply by 2. And then the next one come in, we do the same thing. Because we don't even have to sort it. We just like, this one's already done, so we don't have to. Maybe. And I don't need a counter. I just need a, what do I need? I need a default dict. Right? I'm gonna do sets. So I'm gonna say suff and prefix suffix. Okay. Then we can say for idea in ideas, P and S equals idea, prefix is 0, suffix is idea 1 to the end, right? Now we say suff s dot add P and suff and pref P dot add S. Okay, so we get all that. Then we say rest is 0. We say for suff, for S in suff, right? For S in suff. Then we say for P in pref. Okay, P in pref. Then we say if pref P, right? If S is in pref P, but this suffix, right? Which is S is suffix. Then we go to the prefix. So each one, if it's in there, then we remove it. Then we say pref P dot remove S. Else, if the suffix is not in it, that means this prefix we can use. Then we need to check, right? Then we have the prefix. Then we have to go through every single one, right? Every single suffix. So for SS in pref P, for each one in there, we need to go back to the suffix, right? What do we need? 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 So for each one in this, we need to go through, yeah, for this suffix, and we can do we can set it, right? So this SS, we can say suffix SS is the set, right? Because we're gonna try to match these two. And this set has, no, this is just finding another suffix. I don't see how it makes things easier. But we're saying this prefix is something we can do. So all we need to do is go through the prefix, right? Go through all the prefix and see if they exist in this suffix, right? Or if we can find out how many of them has this as a prefix. How many of them has this as their prefix? So we can go to the prefix, and then we have a bunch of those. Then we say this minus this. I'm not sure how. Otherwise, you'll go through these suffix one by one. Right, go through these suffix one by one, and for each suffix, and you have to go through yours one by one as well. I just feel because we know this is a good, so I can swap in, right? What I don't know is if I swap back, is that gonna be good, right? So I need to know for each one, I have this, I have this bunch, and if I do this minus this, if I do this minus this, then we will get a number that's in this but does not have the start. Okay. Then we can do A, we can do B, we can do C. So it's a slightly different. What we can do is for PP in suffix S, right? We have whatever, and then we do prefix PP, right? We're actually going to say prefix P minus prefix PP, because what we are trying to do is this, right? If I have a set 1, 2, 3, I have another set 1, 2, 4. Okay. If I do A minus B, what do I get? Actually, I don't know. A minus B 3. A minus B is 3. If I do B minus A, it's going to be 4. So that's what I want to do. So I have, this is going to be prefix P. It's this one. This is the current thing that we want, right? I want this minus prefix PP. Then we will get rid of the thing that's they are matching. So I need to know is just the length of this, and that's, we can say current equals 0, right? We can say current plus equal this. We go through all of them, and we collect repeat this. We can basically do all of this. It can be all of this. Let's get all of this. And then we can say rest can be plus equal to 2 times current, right? Then we keep going, and then we swap to the next one. And because we remove So, and then this is 26, right? This is only 26, so this is fine. This is a giant one. This is only 26. For each one, we move it 26 times, but we also need to go through PP. PP is also 26 times because it's suffix, that's PP. So that's 26 times 26 times. You know what? This might actually be right if I can pass the test case. All right, let's see. Simple test cases. We'll see. That's 0. Oof. Can't even get 0. Ideas. All right. Well, we passed these. All right, let's just run. It's okay. It's not right. It's not right. 26 times 26 times n. Oh no, we also have this. Nah, this will take a long time. Ooh, it is correct, but it just takes too long. Jesus. Lord. Nah. There are better ways. There are better ways, man. Oh, we passed quite a lot. Oh, this one just takes so long. All right, so this is, we record this. This is a TLE. God. 8 milliseconds. So we need to be faster. We need to be faster. This set minus set. This thing takes a long time. Can we improve on that? All I want to know is the difference between the two sets. How do we know that? I mean, maybe this set operation is not taking a long time. I mean, there is another way. If we don't do set operation, and we simply just, for PP in this, in suffix s, right? So for each one, we will go through every single one. Oh, that's gonna be, that's gonna take a long time either, because we have to go through every single one of these suffixes, right? We'll go through every single one, and for each one, and check if it's inside. If it's not inside, then we do. So basically what we're saying is, okay, so that's solution 1 doesn't work. What you're suggesting, right? What you're suggesting is we have to do another F for SS in prefix P, right? We're gonna go to suffix SS, no, PP not in, and then we can sum this thing, and we say current plus equal to sum this thing. Not sure. Hold on, let's see. Solution 2. Okay, let's see if this one gets any better. Does this one get any better? All right, so we have 8,000 milliseconds. So we avoid the set operation. Now the complexity is the same. This is gonna TLE 2. Look at this. That's how this one's even worse. This one's even worse. So nah. Oh. Okay. Let's see. For each one, right? We have a suffix. And then each suffix we have is the prefix, okay? And then we want to see all the prefixes starting outside, okay? So we have this prefix. We have a bunch of suffixes. We have another prefix. We have a bunch of suffixes, right? What if they're like the same? We don't have to check it again, so we already check it. Right? So what if because the one good with this doesn't mean it's good with this, doesn't mean so we have to check every single one. So we go to A, we have its thing, right? Now we have D, we have this thing. Yeah, how do we know there's no difference between the two? Bigger prefix. Okay, a different prefix, so I can swap. That's guaranteed. When I swap, is good. But how many I can do the swap? If I swap, right? If I swap, and it will be A. And then I have a bunch of stuff. There's also existing A. Then we cannot do the swap. So we have all of these suffixes, right? We have all these suffixes. And if I want to swap with another letter, right, then we need to make sure after the swap. So what I want to know, what do I want to know? I want to know, given this group, right, for B, how many inside B that's also inside this? Alright, how many inside B is also inside this? So we can do a minus, right? So this minus this, so we remaining is everything in B that is not in A. So now A and B can swap. All of A can swap with all of B, because they are different. They're completely different. Right? A swap here doesn't exist. B can swap there, that will be different as well. Right? So A can do that. So A can swap with C, swap with D, swap with E. I can swap with every single one. Okay, so we can swap is every single one. Now after we finish this, we can say B swap with C. And the outer layer runs. I think this might be right. So we only do prefix. So this time we don't do suffix. So we only do prefix. Okay. I mean, we can even make it simpler. So that's prefix, and then this. Okay. Then what we do is piece equals list pref.keys. Okay. Now we say for I in range len ps, for j in range I plus 1 to len ps. Okay, so we have 2. So all we need to do is pref ps j, right, that's the set, minus pref ps I, that's another set. So this set minus this set. So we remove everything that's in B, that's also in A. Remaining is only in B. Then these two can swap, right? Because they all have A, right? So for this, I can swap with anyone in B because it's an A. So I swap with B to it, right? But I removed it, right? I removed it because you start with A, like all these are unique. Start with B, everything is unique, right? But we might have overlapping. So if we do B minus A, so everything in B does not exist in A. So when A comes in here, because this does not exist, it's like, so when A comes here, that's good. When B comes here, that's good as well. So we do this minus this, right? So everything in A can do everything in B. Everything in B can do everything in A. So now we have is going to be the length of this times the length of pref ps I, and then rest plus equal to that. Of course, it can also rotate, so it's 2 times. And we're just gonna go through everything. Let's see if this one works. Ooh, this one almost doesn't work. Doesn't work in the first one. Okay, that's fine. We can print it out and then check. What do we want to print out? Let's print out prefix. Okay. All right. So C is coffee. Okay. C is offie. All right. C is offie. D is onuts. T is im and offie. Right. So we say C and D. That's 2. C and T, that should be 2. And D and T, that's 4. That's why I got 8. But I think Doffy, dime, donut. Wait, hold on. Coffee and donut. Coffee and time. Donut and time. Donut and toffee. Donut and toffee. Hold on. Coffee and time. Coffee and time. Ooh, coffee cannot be with time because coffee. Oh, so if they are the same. Oh, of course, it cannot do this because coffee and time. C comes in. So if there are similarities, then we just cannot do. But that's a global, right? We're trying to find every single one because one of them and the other one might be able to do. So we need to minus as well. We need to do 2 rounds of minus. 2 rounds of minus. Yeah. Intersection. No. Intersection is not right. So we need to remove and remove. So what you're saying is this is not right. Line of this minus PSJ to this. Then we remove all the things. Then we will pass this. Right? Okay, let's try this. Let's try this. I think we got this. Oh yes, we got this. We got this, baby. Baby. Got this. How should we describe this? Okay, so we create a mapping, right? We create a mapping with prefix, that is the first letter as key, right? And a set of suffixes as value, right? Then for each prefix we can potentially, right, match it to a different prefix. Now to eliminate the impossible, the not allowed cases, it is required that there is no overlap. And we require that all suffixes that exist in the sets of both prefixes are eliminated. We can do this by set subtraction. After we obtain the total number of suffixes in both prefixes that have no overlap, each one in each suffix in one prefix can be matched to each suffix in the other prefix. Thus, the total number of names is the multiplication, is the product. And since we can change the order, right? We can change the order. The product needs to double. We'll keep doing this for each pair of prefixes without repeating. So the runtime is 26 times 26, which is this, times, we can say, n, right? Where n is line ideas. Oh, oopsie doozy, forgot. Okay, check the solution. Group words by their initial. Every pair of initial, then find a number of distinct suffixes in both groups. Yes. Groups. Use set. That's fine. Ooh, there's a number of mutual, and then we just might. Oh, that can actually be fast. I want to do it once. Wow. Just apply to every problem. This is a better one. This is a better one. We don't have to do it twice. We only need to do it once. Okay, this is from the official solution, which is almost exactly the same, but with better implementation, where we only need to do set logic once. We just need to find the overlapping, right? Not overlapping, the repeated, the element, the suffixes that appear in both sets, and deduct their count. We don't have to do set arithmetic twice. So basically we can say repeats, right, shall equal to prefix psi. Oh, I actually never used that before. A and B. Holy crap, you can do that. And prefix psj. Right, this is the repeats. Take the length, and then this will be just the length of this minus repeats, right? And the line of I minus repeats, and boom. That, I think, might be even faster. Not really, but I like this one better. Yeah, it is faster. Jeez. Whoosh. Okay, that's that. Pretty good. All right, good. Yeah, we finished. I'll see you guys tomorrow. Adios.